about counting. When you do counting, when there are finite number of things. So if finiteness is there, then we will talk about counting things. If things are infinite in number, we never about counting. What we are worrying about when things are infinite, what we, what we are talking about when things are infinite. Any idea? You have gone through those kind of terms. If numbers are in infinite, then we never about counting things. We are worrying about convergence, convergence of infinite sequence, convergence of infinite series, or we are talking about approximation. So we talk about approximation, like if you talk about irrational number in the decimal representation, irrational number will have behavior non-repeating or non-terminating in the decimal. So best way to identify the difference between rational and irrational number, see the decimal expansion, and there you will see uh, the irrational number is having either terminating or repeating behavior, but irrational number will have uh, that would be neither terminating nor repeating. So that kind of thing. So best way to identify rational and irrational number. And further, if you talk about irrational numbers, so it is very difficult to uh, go for infinite. There would be infinite kind of non-terminating and non-terminating infinite. It going. So you will talk about your machine is having limitation. Machine can't write infinite decimal representation. So there you have to talk about approximation. And in another way also you can say that it is converging to some finite things. Finite. So convergence or approximation is coming with infinite things. So when we do counting only in case of finite, and if it is infinite we do convergence or approximation. So mathematics later it will be all about approximation. Okay. So, uh, if you talk about principle of countings, it is based on two basic rules. First one is addition rule. The second one is multiplication rule. So we will understand it, and we try to apply everywhere where there is a principle of counting. So what does addition rule say? Okay, uh, it say that when you are applying addition rules, that suppose you are having an experiment, okay, and you are willing to perform that experiment, and there are options, cases, there are various cases, and those cases are mutually exclusive. What does it mean? If you are performing the experiment with the help of one of the case, your job is done. You don't have to bother about other cases, mutually exclusive kind of things. Like suppose you are willing to come to institute, either you will opt for that is institute bus or other that other kind of bus. So if you are coming through institute bus, would you like to take another bus option? No, your job is fulfilled now. So that kind of things. So it just exclude the others. Exclusive. When there is an experiment and you are doing that experiment in are mutually exclusive options, then addition rule is coming into picture. It is all about doing the job. Okay. Just second. Just be attentive here. Be attentive here. Okay. So suppose we have to perform an experiment in R mutually exclusive options, and there are nk choices at the kth option. K varies from 1 to R. There are R options, and each option is having uh, that that we call it kth option is having nk choice. Each option is having certain choices. Okay, so what would be total number of choices? What will be total number of outcomes, or what will be total number of count? It would be sum of the choices in the options, n1 plus n2 plus n3 up to nr. Okay, so that is it. So first question is coming here like that. Suppose there are this one is example one, you can call it. There are 5 action movies, 7 comedy movies, and 16 drama movies playing at the local movie theater. You know, it is a era of multiplexes. So in multiplex there would be several screens. Everyone might be aware of that. Okay, so suppose there are many screens, so these movies are screening there. So if you go to the theater to watch a single movie, and if you are going to watch a movie, definitely you will not go for watching multiple movie. You will go to watch one movie. Okay. Um, so how many choices do you have for which movie to watch? How many choices you will have? Simply here what rule will come? Addition rule will come, because that you have, what is your task? You have to, what is the experiment or what is the task? Task is you have to watch a single movie. Experiment, see clearly what is the experiment. And experiment is watch a single movie. Okay, then you talk about how many options are here, how many cases, case wise, that also. Option 1, how many movies are there? Option 1, 5 movies. Option 2 is talk that n1 is 5, n2 is 7. Option 2, or case, better you can call it case, cases you might have 7. If you talk about option 3, it is having 16 movies. So in total 28 movies options are there. For you 26 8 options are there. So that is simple addition rule. Another question, if you talk about Ravi goes to a pet shop and find that the pet shop has 3 dogs, 4 birds, 5 rabbits, 6 cats. If Ravi can only pick one animal as a pet, how many choices Ravi is having? So it, again here remember that experiment, you have to identify the experiment. What is the experiment here? Pick one animal as a pet. And in how many options you are having? One, two, three, 4 options. You are having 4 options. First option you can carry in 3 ways. N1 equal to, this is N1 equal to 3, N2 equal to 4, N3 equal to 5, N4 equal to 6. So in total how many options Ravi is having? So 3 plus 4 plus 5 plus 6, total 18 options there. So addition rule. Now I am giving a very simple question again. This one is the question number 2. You can call it. Now question number 3. Given a complete deck of cards, how many of the cards are either black face cards or red and even card? Red and even card. Okay, 2 options. Yeah, 2 options are there. Either black face cards or red and even cards. Okay, so this one is question number 3. So definitely the question 3 is relatively harder than question 1 and 2. So how will solve it? So solution, it is very simple kind of thing. Solution you can see it like here. So when you say a deck of cards, so in total how many cards would be there? 52 cards. So everyone might be aware of that. Okay, so in 52 cards you are talking about color. Okay, you are talking about how many type of colors are there? 2 colors, either it will be black or red. Okay, so that easily you can visualize it. So picture is already given here. Since there are 3 faces, it is talking about black face and a black face or red and even. So if you focus on black face, the first face, you talk about face, how many type of faces are there? Cards are of 2 type, either it is numeric or faces. Numeric or faces. Faces, you know that either it will be jack, queen or king. Okay, jack, queen, three kind of faces. And if you talk about red cards with even, red and even, how many options are there? It would be 2, 4, 6, 8, 10. 5 options are there. So that's why a picture I have given here. You can visualize all these. So there are 5 options. There are 5 choices for option 2. This one is option 2, 5 choices. That means so now come to question. 3 faces card in a spade, those would be black. 3 faces card in club, those would be black. black face. It is talking about black face. So 3 plus 3 6 black face. Then 5 would be in heart, that those are red and even. 5 would be in diamond, those are red and even. So 5 plus 5 10. So in total how many options you are having? 3 plus 3 plus 5 plus 5. In total, what I have written, just 16 option. 16 option in total. So simple addition rule is coming here. Okay. Now, if you have understand addition rule, we will talk about multiplication rule. So multiplication rule, it is actually what is happening, that it is one kind of experiment, and that experiment is difficult to do in one go. In one go, someone is asking to complete that work. It is very difficult to do. So what you will do? You will decompose into R options. Yes. So you will decompose into R options. Okay. Do the first option, then go for second option. If Olympiad kind of question, if you are going to solve Olympiad kind of question, solve the first question. If you have already solved the first question, go to second question, third question, like that. So it is decomposition of a, actually that it is a single question in Olympiad. It is a single question. The question has been decomposed into various options or component. And if you are solving first question, then you will move towards second question. If you are solving second question, you will move towards third, and if you are solving third, you will move towards fourth. And in that process, you will be able to solve the fourth question. If you have solved all this, that is the process. So that we call it decomposition. So same thing is here. So if you are having an experiment and you are willing to that perform that experiment, so perform it via a sequence of decomposed component. Either call it component, or call it layers, or call it step, or call it iterations. There are all these are synonymous words. Okay, suppose we perform an experiment via a sequence of R options, where kth options or kth component can be done in nk ways. K varies from 1 to R. So what would be total number of counts or total number of outcome? It would be n1 into n2 into n3 up to nr. So simply it is a multiplication rule. So it is one kind of say that you are filling the boxes. You are having a box of size what R. Okay, you are going up to R. You are having R boxes, and you want to fill R boxes. The first box is the first option. How many options first box is having? N1 option. The second box is having N2 option. Like the last box, that Rth box is having NR option. So that's why in total how many options you are having? How many N1, the multiplication of all these. So this one we call it multiplication rule. So just one question is here. Lily is trying to decide what to wear. Okay, she has shirts in the following color: red, purple, blue. Okay, N1 equal to 3, and she has pants in the following color: black and white. How many different outfit Lily can have? What would be that? 3 into 2. 3 into 2. I am changing the question. Lily has uh, call it uh, 3 uh, skirt, okay, lower pant, and you call, and 2 uh, pajama, something like that, what you call it. Now tell me how many options he is having. Right? What would you option? What would you, addition or multiplication rule? Addition rule. No one will uh, want to wear two lower dress at the same time. Okay, so that there, so you have to see the frame of question. From the question itself you have to frame different kind of question. So, okay, so answer is here for this current question, answer is 6, 3 into 2, 6. Any question here till now? I think all these are very simple questions. Now you go to check out their the, check out 3 books at the library, and you want one history book, one science book, and one fantasy book. How many of you know the great few special fantasy book. Any specific fantasy book? Harry Potter. Okay, that means you are not giving attention to Indian culture. Any other? Don't. I'm just joking. Okay. Any other? What? What? Enable prison? Okay. That. And any other? What? That one is not fantasy. Any one of you heard Chandrakanta? Something like that? Not. Those are very old kind of. Or Shaktiman. Everyone. Actually, your age, our age, during our childhood, we had watched a lot. There are many. Like in Indian version also you can see a lot of options are there, and also if you go in actually we are always fantasized by Western things, but we are having a lot of interesting things. So uh, simply so that a student is going to check three books at the library, and you want one history book, one science book, and one fantasy book. So the library has 50 history book, 95 fantasy book, and 30 books are from science. So how many total choices would be there? How many total choices would be there? It is just multiplication, simply multiplication is coming. Now, another question. This one is the interesting question. Counting number of subset in a given set of cardinality n. So, call it question. This one would be question 3, exercise 3. So, you count number of subset in a set having n element. So, how you will count it? Through multiplication rule. So, let A be a consider A be a set having cardinality n. N is a finite number, and when someone is saying that n is less than infinity, means it is a finite number. N is less than infinity. So, how many distinct subset A may have? So, solution is very simple. That consider a set, simplest one, 1 2 3 4 5 up to n. That means it is having n element. Now, B is a subset, any subset of A. So we have to find how many such B would be there. So what kind of, so the scenario will come here like this way. The experiment you have divided into R options, n options. How it is coming? So take B. Now in A you observe 1 2 3 4 5. In the first experiment or first option, you will look for one whether in B or not B. How many options are there? If you are taking one, whether it would be if you are taking one, the one would be either in B or not in B. So only two options. So n1 equal to 2. Likewise take 2, and you will verify whether 2, you will check for whether 2 is in B or not. So how many options in option 2? 2. Like in n3, 2. So like in nth option, how many ways? 2. So how many total choices are there? 2 to the power n. 2 into 2 into 2, how many times? N times 2 to the power. So it is count of number of subset in a given set of n element. Okay. So now there is another principle. This you call it inclusion exclusion principle. It is also very much interesting. Okay. Inclusion include and exclude. What does it mean? Why you are excluding? If you are including, then why you are excluding? Yeah. So even this looks very easy, but the problem based on this will be much more complicated. Even a more detailed explanation also you will get in discrete mathematics. In discrete mathematics you will call it. So in an experiment, consider A and B are two non-disjoint event. It is something different from addition rule. Something different from addition rule. So we are in the addition rule we had disjoint or mutually exclusive. Mutually exclusive is more general than mutually disjoint. Uh, Anyone know the difference between mutually exclusive and mutually disjoint? What is meaning of mutually disjoint? mutually mutually disjoint. In short, we will write it MD. So when two elements are mutually disjoint, A intersection B equal to phi. Fine. So that A intersection B, actually I have uploaded a book in the archive on probability and statistics. You can find all these definitions. I have mentioned most of content are from the book. Now, what is meaning of mutually exclusive? What? Anyone? Independent. Have I discussed independent till now? What I have discussed? I have discussed probability measure. I have discussed event and other kind of things. So try to answer from that what I had discussed. Don't go what I haven't discussed. I won't discuss independence before conditional probability. So what is mutually exclusive? A union. Try to explain it. Mutually exclusive. Give emphasis to the word, not what we have remembered from somewhere or layman way. What? No, I haven't discussed independent. Any other? Try to. Definitely, you might have already studied that mutually exclusive. What is meaning of mutually exclusive? Just any other? Then how you will score marks if I am giving simple question? You will say that it is very simple. I have already answered. Actually, you have answered wrongly. What is mutually exclusive? Exclusive, mutually exclusive. That means both can't occur together. Happening of one kills the happening of other. Exclude. Happening of one kills the happening of other. Exclude. Happening of one exclude the happening of other. That's a mutually exclusive. Exclude. Mutually exclusive. Happening of one, if you are tossing a coin, if you are getting head, it will exclude the getting of tail. So that's why getting a head and getting a tail both are mutually exclusive. So happening word, that means probability measure will come there. So that means what, how mutually exclusive event defined? If you say that if you are having two event and probability of joint occurrence of those two event is 0, then you will say that those two event would be mutually exclusive. That is the actual definition of mutually exclusive. And if you say that okay, A intersection B is phi, so probability of this word would be also equal to 0 now if you are computing probability. And actually the mutually disjoint is a special case of mutually exclusive. Mutually. Why? Anyone? Or anyone can give example where mutually exclusive is more general than mutually disjoint. This is the definition of mutually exclusive. When joint occurrence of A and B is 0, the probability of joint occurrence of A and B is 0, then we will say that A and B are mutually exclusive. So occurrence, it is dealing with occurrence. Okay, chances. It is dealing with chances. So that is. So have you seen this thing? P implies Q. Anywhere have you seen this? Have you seen this or not? Where you have you seen this or not? In plus 2 mathematics, nowhere you have seen. Uh, Definitely there is there. There is. What? You have seen, actually, but you have seen, but you haven't understand actually. So, if one statement you might have already seen that a rational number, any rational number can't be expressed in term of P by Q when P and Q are rational integers and Q is not equal to 0. So that, so if you are saying x is an irrational number, it implies x is not equal to P by Q. That one is the mathematical notation. In sentence it will take longer time. When x is irrational, then x is not cannot be written in term of P by Q form. And in mathematically you will write, if x belongs to Q complement irrational, then it implies x is not equal to P by Q. So implies word is coming there. This we read it implies, P implies Q. So uh, what does it other, it is having another meaning as well. In discrete mathematics you will see a lot, all these are part of logic. So P is included within Q. You say in short way, the Venn diagram, you can say that actually Q is no more actually considered just as set. It may be anything, any statement. Generally it is a statement I am talking, and Q is this. Q is within, Q is within P. If I say when P implies Q is false, when it is false, P is within Q. When someone is saying that uh, P is true and Q is false, is it possible? P is within Q itself. If Q is false, by default, uh, okay. So if someone is saying that no, say like P is false and Q is true, it is possible. If Q is false and P is true, definitely. So P is within Q now. So those things actually part of the discrete mathematics. Later you will come to know. So just you need to know all the implication in mathematics. If you start mathematics, implication is coming everywhere. Implication, every mathematical theorem or definition are actually in term of implication, are in term of implication. So you need to know all those. Okay, so here I am coming back to here, that inclusion exclusion principle. Consider A and B are two non disjoint event. I am not taking mutually disjoint or mutually exclusive, I am taking non disjoint event. Then total occurrence of the outcome from A and B, it will be given by uh, number of outcome in A plus number of outcome in B. Then in A, while counting number of outcome in A, we had also counted joint occurrence of the outcome which are in A and B both. Also we have counted here in the process of counting number of outcome in B, we have also counted a joint occurrence of A and B. So two times we have counted, so we have to subtract one time now. So that's why we are subtracting it, outcome, common outcomes in A and B here. So that's why here inclusion is happening and here exclusion is happening. It is simply inclusion exclusion principle. So one simple question is coming: how many positive integers not bigger than 20 are divisible by either 2 or 3? So how will find number of integers divisible by 2? How how many? Okay, up to 20. Up to 20, we are going up to 20 divisible by 2. How many numbers it would be? Just you do take divide 20 by 2 and take greatest integer. Okay, so 20 by 10, 20 by 2 is 10. So A will have count 10 and B will have count 20 by 3. So 20 by 3 is, so just have to, greatest integer you have to take, that it contains, okay, 6. And uh, so here while computing uh, divisibility by 2 and 3, it has also included divisibility by 2 into 3, that means 6 also. So you have to exclude that common thing. So how many numbers which are divisible by 16 up to 20 numbers? So 20 by 6, so it would be 3. So it would be total answer would be what? It would be 10 plus 6 minus 3. The answer is 13. So all these are very simple question. And now if you talk about the counting principle, application of counting principle, there are 4 ways you can talk about. 4 ways there are counting. So if you are counting principle, that means you are forming this cell, you are having cell forming this cell, k options, k cells are there, k cells out of n numbers. So how many way you can form uh, the, these numbers, you can construct these numbers, you can fill these cells, how many ways, how many n number of ways, it is not like that. So question is that what are the possible scenario, what are the possible scenario. So here when you are it is actually we say that it is one kind of thing, we are forming sampling. How many samples can be formed, a sample of size k can be formed from out of n elements, out of, we are having n number of given element, and from the n number of given element we are willing to form, so n number of given element objects are having, and we are willing to form a sample of size k. So this sample of size k, say k means we are having k box, call it k box, there are k box. So how many scenario, first you have to talk about scenario, what are the possible scenario when you are forming a sample of size k, or simply you are having n alphabets, from n alphabet you are willing to form a word of size 6, that means box of length 6, you are having a box of length 6. So how many such boxes there would be, n would be 26, in English alphabet there are 26 letters, and so tell me how many words of length 6 would be there, 26 to the power, then I am putting it meaningful words, then what would be that, 26 to in that way you will say that largest possibility 26 to the power 6, then I am saying that meaningful words. So what, how you will do that, every combination of word is not meaningful, various things are there, so that you have to see it. So that's why scenario, you have to consider scenario. Scenario is coming that repetition and order, sometime there would be repetition will be allowed, sometime order will be allowed, sometime order will be not allowed, repetition will be not allowed. So how many possible scenario would be there, 4 scenario, there would be 4, repetition and order, repetition and not order, not repetition and order, not repetition and not order, so that 4 possibilities are there. So some general terminology of counting problems that show up in probability to make sure that the language that we use is precise and clear, it would must be clear. So here first word is coming sampling, sampling, that means we are forming a box of numbers, from a given set of number we are forming sampling box of number, so that box will not contain all the possible given number, it will contain some part of number. So that's why that is the meaning of sampling. Okay, that means if someone is asking to compute average height of Indian people, so what you will start, I have given you task to come up with average height of Indian people, what you will do, you will go and measure every individual Indian, no, it is a very difficult task, so cumbersome job. So you will do sampling. What is meaning of sampling, that means sampling means random sampling, that means it is a very random choice, you will go and pick any given 100 people from anywhere and measure the height of those people and average it, so one average, go another place, take further 100 people, measure the height of those people and take average. Okay, then go other place, take 100 people, measure the height and find the average, that those are sample average, those are sample average. So how many samples, how many that such kind of samples you might have taken, uh, it is up to your choice, you can go for 100 sample, 1000 sample, like that. So with respect to each sample you got a sample average, so you sum all these sample and divide by number of counts, so that will give approximate average height of Indian people, that is the, so it is approximation kind of thing. So when one task is very difficult to do, you do through approximation, so that we call it sampling approach. Okay, so here two things are very important. One, I had told that you're going uh, to measure height of 100 people from one place. So 100 is very important. That one is size of sample. Then how many sample of 100 size? How many such sample you have already done? How many such? 100 people from this place, then 100 people from that place, then that place, that place. So how many time of that things? So that one is counting number of samples. One is sample size. How many samples you have taken of that particular size? So that one is actually that will come in denominator when you are trying to find estimate average height of Indian people. So do you know here two things are coming here? One is size of sample, how many samples. So don't confuse with all those. I think you all have already completed statistics course. Have you seen that two difference? Sample size and number of samples. Number of samples and sample size. Those two are very different things. Don't confuse it. Many people are doing confusion. So then central limit theorem will come there. Okay. So here sampling thing everyone might be comfortable with. So sampling from a set means choosing an element from the set, and we often draw a sample at random. We never give priority to any specific element. We draw a sample at random from a given set in which each element of the set is having equal chance of being chosen, or equally likely situation. Uniform distribution simply we call it. So there are situation either we will go for with or without replacement. Usually we draw multiple samples from a set. That means how many samples? Multiple samples from a set, and here either we will go with replacement or without replacement. So if you do perform sampling with replacement, okay, so if we put each object back, the replacement this after selection we put it back in the set. Okay, so if we put it back after each draw, we call this sampling with replacement. In this case, a single object can possibly chosen multiple times. Can be. So sampling with replacement. So suppose you are having a set having 4 objects A1, A2, A3, A4, okay, and we pick 3 element with replacement. So what are the possible outcome would be there? It would be so this one A3, A1, A3. This can be a possible outcome. Here A3 repeats because repeat and replacement both are same. Thus with replacement means repetition is allowed. And on the other hand, if repetition is not allowed, we call it sampling without replacement. So such scenario is like that. We say that A1, A2, A3 is not equal to A2, A3, A1. Sorry, order. Next we talk about order. So order or unordered. So here order is very much essential. If you consider order. So here if you are considering order, then order matters. How? So here we will say that A1, A2, A3 is not equal to A2, A3, A1. It is not equal to when order matters. That means sequence pattern, sequential pattern. So if you go in Q is a very special example of sequence. So this order matters there. No one want to get a ticket first by coming late. No one want. So order matters there. So this is called order sampling. Otherwise, if there is no order, then it would be unordered. People are gathering in a public place in order to celebrate something. Order is matter there. If you are going to participate in a music fest, order is matter there? No. So that unordered things. So the sampling from set have 4 possibilities. First one is ordered sampling with replacement. Second one, order sampling without replacement. Third, unordered sampling without replacement. Fourth, unordered sampling with replacement. Tell me which one is the toughest one? Yeah. So that we will see. That we have to count all those. So first one is order sampling with replacement. So consider a set with n element. Simplest we are taking A is equal to a set having 1, 2, 3, 4, 5 up to n elements. And we want to draw k samples from the set such that order matters, repetition is not allowed. Oh sorry, repetition is allowed. Orders matter and repetition is allowed. Ordered with repetition. So that means we are having an object and we are willing to form a sample of size k. That means we are having k box. We have to fill k box from n objects. So like this scenario is coming. First box, second box, and k box. K box we are saying that n objects given. So simplest example, take n equal to 3 and k equal to 2. K equal to 2. So that means we are having to fill 2 box from 3 elements, 3 objects we have to. So how many choices are there? If repetition is not there, order matters. How many choices would be there? So 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3. So you can see that here if you talk about 1 2 and 2 1, both are different. Order matters here. Repetition is already. So how many choices are there? 9 choices. So the first box can be filled in 3 way and the second box can be also filled in 3 way, because repetition is allowed and order is matter. So the count is 3 into 3. 3 into 3 total 9. Order with replacement. Okay, so we can generalize it. So means there are k positions, k boxes in the list. Call it position 1, position 2, position k, and there are n options from which we can fill these k positions. Okay, thus we are, when ordering matters and repetition is allowed, the total number of ways to choose k objects from a set with n element, we call it n to the power k, n into n into n into n to the power k. So this number, order and replacement. Okay, a special case of multiplication rule where there are k experiment and each experiment is having n possible. Okay, so just one. Okay, it should not come here. If k equal to n, what would be that? N to the power n. All these are simple. Now that first one was simple. Order sampling without replacement. What is the name of this? We call it permutation. Name is permutation. Order sampling without replacement. So what we do here, we consider a set with n element and we want to draw k samples from the set such that order matters but repetition is not allowed. That means we are having a box here, k number of box, and we want to fill with n numbers. In such a way order matters but repetition is not allowed. The first box, so for example, if n equal to 3 and k equal to 2, that means we want to fill 2 boxes from 3 number, and their order matters and repetition is not allowed. So the first box is having how many choice? 3, and the second box 2. Why? Because 1 is already consumed by the first box. So in total how many choices are there? 3 into 2, total 6 choices are there. What are those choices? What are those samples? 1 2 1 3 2 1 2 3 3 1 3 2. These are the choices. You have to visualize the choices as well. What are the choices from this number? Or these we call it samples. So in total samples, how many? So it is here two things are here. We are taking a sample of size 2. How many sample of size 2? 6 sample of size 2. That one is coming from principle of counting, and sample of size 2 we are fixing it. How many samples of size we are willing to go. So there are two things: sample of size, k is the sample of size, and that npk would be total number of samples in this situation when order matters and replacement is not allowed. Okay, so we say that means there are k position in the list and there are n option. For position 1, how many options are there? N option. For position 2, how many options are there? N minus 1. So you can say it like this way: here n option, here n minus 1, and the kth position will have how many option? N minus k plus 1 option. The kth position will have n minus k plus 1 option. So total number of count would be, total number of possible outcome would be n into n minus 1 into n minus 2 up to n minus k plus 1. And if you are willing to write in a very systematic form, then we write it like this way. That means take factorial n, that factorial n contains n number of products, n into n minus 1 into n minus 2, it will go up to 1. So it is containing n product of first n natural numbers. And what we do, we are worrying about product of last k uh, last k natural number up to n, last k natural number. Okay, so we have to truncate the first n minus k, we have to truncate first n minus k. So the truncation is coming through this denominator, we have to cancel it, cancel. So from factorial n we have to cancel. So this one is talking about product of first n minus k natural number, so we have to cancel it. So that's where this formula we call it npk, npk, the permutation. Okay, so a special case of multiplication rule, it is where there are k experiment having n1. So it is simply we can say that it is a very special case of multiplication rule. You can say that n1 equal to n, n2 equal to n minus 1, nk equal to n minus k plus 1. It is a special case of multiplication rule. We can, this permutation we can say that it is a special case of multiplication rule. Okay, so if one example is here, if the k people are at a party, what is the probability that at least two of them have the same birthday? Suppose that there are 365 days in a year. Okay, and all days are equally likely to be the birthday of a specific person. So how you will solve this problem? So you consider here a be the event that at least two of them have the same birthday. Okay, so if k number of people are greater than 365, what will happen? What is the probability of a? If number of people are greater than 365, definitely probability of a would be equal to 1. Definitely 2% will have the same birthday now. If k is greater than n, then 2% definitely you will get give record birthday of 365 people, and then additional coming repetition of birthday will come there. So that, so probability is 1. Now situation will be difficult when k is less than equal to n, or k is less than n. So in that case you can go in a complement way. So you have to a complement is what you will call it, what is the negation of this one? If you are saying at least two of them have the same birthday, what is the negation of this one? What is negative of this one? No one have the same birthday, no one have this, that one is the a complement. How many numbers it would be? It would be npk, simply npk, you can count it like that. And that means it will give the probability of a. Probability of a is what? 1 minus probability of a complement, that everyone know. Okay, a complement. I simplify it, you will get it like, so it would be a function of k, it would be a function of k, and take different k, you will get different probability of a, different k, it is a function of k. So I have taken two scenario, when k is 57, probability is coming, k is 23, probability is coming as 0.5073. When k is 57, probability is coming 0.99. If you are changing k, your value of probability of a, it is changing, it is not fixed, it is changing like that. Now another situation, second situation, that we are taking unordered sampling without replacement. That means no order, no replacement. Okay, so this we call it what? What is the name of this? Anyone? When you are performing sampling or selection of numbers, selection of k numbers, sampling or selection of k number out of n numbers, in simple we call it sampling. So what is the name of this one? Combination, we call it combination. So here consider a set with n element. Suppose a is having element 1 2 3 4 5 up to n, and we want to draw k sample, a sample of size k. But k sample means a sample of size k. K samples, here you can read all possible k samples, plural is coming. That means a sample of size k. That means we are forming a box, there is a box with k cells, k boxes. Simply we say that k boxes. There are k boxes from an element. We are willing to form this. Okay, if here if you are taking it n equal to 3, n equal to 3 and k equal to 2, that means we are forming a box of size 2. So this will have how many options? The first box will have 3 options, second box will have 2 options, that we are taking without replacement, but also we are not worrying about order. We should not take. So in that case 1 2 and 2 1 both will same now. It is grouping, or no ordering means grouping. We do grouping, we never focus on the individual one, we do grouping, or grouping of 1 2. So 1 2 and 2 1 both are same, it is set kind of thing. Okay, so we have to once here it would be 3 by into uh, 2 choices, but here what is happening that taken 2 at a time, that those will what same now. So we have to do cancellation by factorial k, yeah, factorial 2. So here it would be equal to 6, and we are willing to count number of samples, so we have to divide it by the factorial of size of the boxes. Factorial 2, you have to divide it by factorial 2. What is the value of factorial 2? It is 2. So effectively what is the value of this count? It would be actually equal to 3. There are 3 possibilities. There are 3 processes. So did you get answer? In the last lecture I had raised an answer. Which one come first, permutation or combination? I had asked a question now. Which one come first, permutation or combination? Permutation. So is it clear to everyone that if you are talking about this principle of countings, the permutation should come first, then you will talk about combination. So that's the thing. Okay. So what does it mean? There are k positions in the chosen list, position 1, position 2, position up to position k, and there are n options for position 1, n minus 1 option for position 2, n minus k plus 1 option for position k, and the counting is normalized, either factor or normalized also. Counting should be normalized by factorial k. Why? Repetition is order is not order is immaterial there. We are taking honor. So 1 2 3 4 5 is same, 5 4 3 2 1, like that. So you have to normalize it. So how you are normalizing it? You normalize it by factorial k. So that's way the number of combination, it would be what, n1 into n minus 1 up to n minus k divided by normalized things, and this quantity we write it factorial n divided by factorial k into factorial n minus k, and this we call it n choose k. We read it n choose k. Choosing word is coming. When we are saying that choosing word, take 10 people, put it in group. Take further 8 people, put in a group. So grouping, we do perform grouping. We are not giving attention to order. We are forming grouping kind of thing. So n choose k, it is also equal to n choose n minus k. So it is one kind of binary things. It is a binary things. If I am giving you task that there are 100 people, then form a group of 50 people. What you will do? You will select 50 people and put in a group. Then you have in that process you have also done form another group. What is that group? Those person which you haven't selected. So 50 you have selected in one group, and those not selected in, it will come in another group. So there are two groups. Binomial things are there. Binomial things are there. So when you are talking about selection, by default you perform selection of k people out of n people. By default you perform binary selection. That means you are saying forming a group, you call it selected people are coming in group, then failure people are in the another group, the next group. So that means if you're talking about n choose k, that means at the same time also you're talking about n choose n minus k. So that's way n choose k is equal to n choose n minus k. Okay, is it clear to everyone? Okay, so a special case of multiplication, again I will say that it is a special case of multiplication rule. N1 equal to n, n2 equal to n minus 1, and okay, likewise nk equal to n minus k plus 1, and then we normalize it by factorial k. Okay, all these things. So one example I have taken it here. It is very simple example, you can take it. So how many distinct sequence can we make using three words age and 5 letter B's? Three letters age and 5 letters B. How many distinct? So first you have to decide the size of word. What would be, you are taking 3 age and 5 age. In total, what would be the size of the word? 3 plus 5, 8. Okay, so if you are forming with selection of 8 choose 3, it would be equal to, it is selection with bj. What, how many b's are there? 5. So 8 choose b. So both are 8. 8 choose 3 is equal to 8 choose b. Very simple thing. Now, little bit complicacy here is that you are talking about unordered sampling. Order is not matter with replacement. Then what situation will come in? You do perform replacement, but you don't care about order. So situation is coming here that consider a set with n element, and we want to draw k sample. That again every time I am saying that k boxes here. Actually, box approach idea, if you see cases in a book, actually he has used that boxes approach a lot. So I like that approach. Okay. Okay, second sample such that ordering is not matter and repetition is allowed. So here just take n equal to 3 and k equal to 2. Then how many options are there? You are talking about sample of size 2. How many options are there? That means here there are 2 boxes. Okay, so 1 1 1 2 1 3, and repetition is allowed, order is not. So 1 1 1 2 1 3 2 2 2 3 and 3 3. So, so actually no, this will come now. Order uh, unordered and replacement. So replacement, you can see it here. Replacement. So unordered means we have removed 2 1 1 2 we are having, we have removed 2 1. Then 1 3 we are having, we have removed 3 1. So start with 1, first entry 1. So 1 1 1 2 1 3. Fine, there is no issue. So how many possible samples are there? You can list it out. How many in total? If you don't put any condition, in total actually generally you put 9 possibilities are there. 1 1 1 2 1 3, then what will I start? First entry would be now the first entry as 1 has exhausted. Now we will go for 2 as a first entry. So we will talk about 2 1 2 2 2 3. Now 2 as a first entry has been exhausted. So we will go for 3. We will talk about 3 1 3 2 then 3 3. How many possibilities are there? In that case 9 possibilities. Now in the 9 we are putting a condition that unordered order, that order is not matter. Order is not matter. What does it mean? We will one of 1 2 and 2 1 both are same. 1 3 and 3 1 both are same. 2 3 and 3 2 both are same. So how many things has been reduced? From 9 we have reduced 3. So 6. Now second condition we are putting it, replacement is allowed. If no, it is not without replacement, then we should remove these 3 3 1 1 all these. So we are not. So in total here how many options we are having? 6 different possibilities. 6 different possibilities. So these are the possibilities. Is it clear to everyone? Unordered sampling with replacement. So in the case of here 6 possibilities are there. Okay. So if you are willing to compute as an count, how you will count it? Same thing, how you will count it? It is relatively difficult than previous two options. So how will count it? So counting process, it is coming here separately. We have to. It is how many of you know about decomposition of integers? Here all you are dealing with positive integers. How many of you are familiar with decomposition of positive integers? Have you heard decomposition or partition of integers? Okay. Actually, those are Olympiad kind of things. If you are preparing for Olympiad, those are very much meaningful things. So here, there are various ways to come up with count, the desired count. So here, if you one approach is any of the pair in the above list can be represented by number of ones, number of twos, or number of threes as it contains. Okay, that if you call it here, that is x1 is counting number of ones, x2 is counting number of twos, and x3 is counting number of threes. Okay, why? Because we are having three numbers. We are having three numbers 1, 2, 3, and from that we are willing to form a sample of size 2 where order is not matter, repetition is allowed. Order is not matter, repetition is allowed. So there we will count number of ones in the first place, number of ones, number of twos, number of threes. We have to count number of ones, number of twos, first or second, whatever it will be. So we are having a sample of size 2. So here we are counting number of ones, a number of twos, or number of threes, that we are counting. So that one is countable things. Okay. So we here call it 1 1. How will represent? We will represent as a 3 tuple. Why 3 tuple? Because we have taken n equal to 3. 3 object we have taken. From the 3 object we are forming a sample of size 2. Sample of size 2. That means you are filling 2 box from 3 object in such a way that order is not matter, repetition is allowed. So that 2 tuple we will have. This 2 tuple can be written in term of 3 tuples. 3 tuples involves with number of entries, or number of ones, number of two, number of three, like because 3 type of numbers now. So 2 tuple as a sample is equivalent to 3 tuple. Are you familiar with tuple or not? Tuple, are you familiar with that or not? Order pair, everyone is familiar with order pair, I comma j. But if you are talking about 3 things coming together, then we can't say it order pair. We have to talk about 3 tuple, 4 tuple, that kind of thing. So tuple, that one is tuple. So if you talk about 1 1, we are writing the sample 1 1, we are writing as a 3 tuple. Why? Because n equal to 3 here. 3 object, we are forming it from 3 object. So x1 is counting number of ones. How many number of ones here? How many number of ones in the first sample? 1 1. How many number of ones are there? Just count number of one. How many? 1 2 2 2 1 are there. So that's why x1 equal to 2. How many 2 you observe in this first sample? 1 1 0. So x2 equal to 0. And how many 3 you observe in the first sample of size 2? It is 0. So 1 1 is equivalent to 2 0 0. Then 1 2 1 2 is equivalent to how many 1 are there? 1. How many 2 are there? 1. How many 3 are there? 0. So 1 2, the sample, second sample is equivalent to 1 1 0. Third sample is equivalent to 1 3. It is actually partition. We are doing partitioning of what? A partitioning of 2. Here okay. Then 1 3, it is equivalent to we are doing partitioning 2, a sample of size 2 now. Sample of size 2, 2 boxes we have taken. So we are doing partition of k, a sample of size k we are forming. Then we are doing partitioning of k, and in term of n object, okay, k. So here 1 3, it is equivalent to how many 1 1, how many 2 0, how many 3 1. So one sample, it is sample 1 3 is sample of size 2, and it is equivalent to 1 0 1. So what actually we have done here in all these? There are 6 in total samples with unordered and sampling. So we have done actually partitioning of 2 into these 3 factors. X1 is counting number of ones, x2 is counting number of 2, x3 is counting number of 3, number of 3. So we are partitioning 2 into these numbers. So xi will take value from 0 to 2. So how many way 2 you can partition? How many way you can partition 2? There is another approach to find it. One approach is here through counting. How many ways? So total possibilities are 6. Total possibilities here it would be 6. So how we got that formula? So formula is coming like here. It is so this principle that total number of distinct k samples from an element such that repetition is allowed and order doesn't matter is the same as number of distinct solution to this integral equation. Why I am calling it integral equation? K is an integer. K is an integer, so integral, and the solution would be also integer. So the partition member would be all integer. All it would be integers. So it is equivalent to say that how many n plus k minus 1 choose k, and it is just equivalent to just what, n plus k minus k, subtract from this k, and then this would be equivalent. It is just a n choose k is equal to n choose n minus k. Same formula is coming here. So how, if you talk about this representation, how many structure you observe here? How many structure you observe here? First you will say that I observe n structure. What are those structure? X1, x2, x3, x2, x3, x4 up to xn. So n. And now after that n structure, what other you observe here? You observe plus. How many plus are there? How many plus there in this equation? How many plus? N minus. Here. Here how many? Okay, n minus 1 plus sign. N minus 1 plus sign. You will see that. N minus 1 plus sign you observe. Okay, n minus 1 plus sign. And the how many xi's are? N xi. In those n xi, what are the possible value xi's are taking? It is taking value from 0 to k. So k possibilities are there now. So 0 will have meaningless thing. 1 will contribute. 0 will have meaningless contribution. 1 will contribute there now. 0 means anything. If you are saying that 4, you can write it 2 plus 1 plus 1. You can write 2 plus 2 plus 0. You can write 3 plus 1 plus 0. So like that, 0 is not contributing much. So effectively you will say that xi is contributing k vertical lines. K vertical lines, replace it by vertical lines, that means meaningful non-zero value of xi. So how many vertical lines it would be? K vertical lines. So in total how many structure you will observe here? That effective one, how many total structure you will observe? N minus k plus 1. So n minus k plus 1, or better you can say that n plus k minus 1. Okay, n and k, those are general things, na, and minus 1 is a specific thing. So and from there we are choosing k. We are choosing k element. Xi is taking value from this. Okay. So here it would be n plus k minus 1 choose k. So when unordered sampling is there with replacement, what is the total number of count? N plus k minus 1 choose k. So it is just saying that the equation is equivalent to say that it is represented by k vertical lines, xi will be replaced by k vertical lines, and n minus 1 plus signs. So in total structures, how many structure you observe? n plus k minus 1 option structure. From there you are choosing k things. So it is partitioning. We are partitioning k with the help of n given distinct object. So it is partitioning kind of thing. So you can. So this is the count. I think this is the toughest one among all the 4 options. This is the toughest one. You have to just work on it. Just I will finish. Unordered sampling with replacement, it will continue. So one question is coming here. 10 passenger get on airport shuttle at the airport. The shuttle has a route that include 5 hotels, and each passenger get up the shuttle at his or her hotel. So the driver records how many passengers leave the shuttle at each hotel. So tell me how many possibilities are there, possibility of exist. So in total how many hotels are there? 5 hotels. How many passengers are there? 10 passengers. 10 are there. Actually I have written in a word, it should be in numeric, better. So 10 passengers are there. So actually k equal to 10, k equal to 10, and n equal to 5. And it is all about when you are talking about dropping passenger in the hotels, it is one kind of partitioning 10 passengers in hotel. So we do 10 equal to x1 plus x2, it is up to x5. So and xi's are taking value from 0, 1 to up to 10 xi. So these are the passengers. So how many way we can perform that? It would be again the same formula, n plus k minus 1 choose k, and the simplification is coming here. 14 choose 10, 14 choose 10. This is the count. Okay. So number of ways of drawing k object from a set with an element in 4 different ways. 4 different ways. As first one, again I am repeating it. And, uh, ordered sampling with replacement, ordered sampling without replacement. Ordered sampling with replacement, we do not call it count n choose k. Sorry, n to the power k. Ordered sampling without replacement, npk. Or unordered sampling without replacement, we call it n choose k or nck. And unordered sampling with replacement, we say it n plus k minus 1 choose k. So these are the 4 possibilities of counting principles as an application of basic multiplication and addition rules. So you can get it like in this way. So all these will help to solve